Alright, so now we're going to start on z-scores, which are kind of one of the tougher bits in statistics, so make sure to pay attention. So we've seen the z-score formula before, that z is equal to x minus mu divided by the standard deviation, and we know about our standard normal distributions. We have 0, 1, minus 1, etc. And you guys might have seen this before. So these are the standard normal tables, alright? So basically what these do is, they calculate the area below certain points on the standard normal distribution. So for example, if you take, so remember we have 0 in the middle, we have plus 1, and we have say minus 1. But if you want to take the point 1.5 for example, so it's 1.5 standard deviations, and you want to find the area or the data, amount of data behind this in the standard norm, or in the normal distribution, you have to go to the table. So you can calculate it manually if you want, but it's a lot harder. So going to the tables is the easy thing to do. And these are in your formula books. This is what you'll do during the exam. So the way you read it is, you go down, so this column here, I'll change to a different color that's a little bit easier to see, go red. You go to this column here, and you're going to go down until you find 1.5. So then we're going to go down, 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 until here it is 1.5 right here. And in this case, all we need to do is just go 1.5 and then look at 0.00, so this bit here. So this is going to be our answer, 0.9332. For example, if we wanted to find, I know this is not to scale, 1.56, then again we'd go down to 1.5 and then we'd go across until we get to 0.06. So then we have 1.56. Okay, so what does that answer mean? I'll go back a little bit. So our answer is 0.9332. So that means the green shaded area I have there is 93.32%. Okay, and we'll see what that means in a real life question later, but hopefully that just explains how to read the standard normal distribution. So the interesting thing is that the standard normal distribution only reads what's below a certain point, so to the left, and it only starts at 0.5. Okay, so it only starts bang in the middle, and the reason for that is that it's symmetrical. So there's some ways around getting, say for example, if we wanted to find, see where I'm drawing the red line, if we wanted to find what's below minus 1, there's a way around it. Okay, and we'll look at that in the next few videos. Let's get rid of some of these markings. Yeah, okay. Yeah, so we're going to have a look at an example question that'll teach us how to use the standard normal tables. So the same numbers we had last time. So the height of adult Irish males has a mean of 176.3 centimeters and a standard deviation of 7.1 centimeters. So what is the probability that a randomly selected Irish male or adult Irish male will be shorter than 180 centimeters? Okay, so that might seem like a difficult way of asking the question. And also the next one, what proportion or percentage will be taller than 185 centimeters? But we'll see that it's just sort of fancy words. It's just using the standard normal tables, things we've sort of already done before. All right, so I'll start with the first one. What's the probability that a randomly selected Irish male will be shorter than 180 centimeters? So the first thing we do is we turn 180 centimeters into a z-score. So 180 into z. So we're going to say that z is equal to 180 minus, so in this case 180 is the x, then we're looking for mu and the standard deviation as well to finish the formula to find the z-score, minus 176.3 divided by 7.1, and that's equal to roughly, so I'll say z is equal to 0.52. Okay, so that is our z-score. So someone who's 180 centimeters tall is 0.52 of the standard deviation above the mean. Right? So if we want to go to our thing here, if we're saying that this is our mean, which is 0, and let's say this is our 1, which is 1 standard deviation, then 180 centimeters will be somewhere here, 0.52. Alright? And if it asks, what is the probability that a randomly selected adult Irish male will be shorter than 180 centimeters? Basically what that means is it wants us to find the area behind 0.52 on the standard normal distribution. Because if we were to randomly select someone out of the, say like one data point out of the standard normal distribution, there's going to be, depending on the amount of area behind this, that's the chance that they're going to be smaller than 180 centimeters, and then the amount of data in front of it, that's the chance that they're going to be taller than 180 centimeters. So hopefully that makes sense. But we'll get lots of practice doing it anyway, so you'll kind of get used to it. So the probability that someone is shorter than 180, so we're looking for 0.52 and then the area behind it. And I'll just quickly, before I do it on the standard normal distribution, I'm just going to write P of Z less than 0.52. So that's the probability that Z is going to be less than 0.52, and that's sort of just the way that we write these things, okay? So if you're looking for the probability that someone is going to be shorter than 180 centimeters, you write it as P of Z less than 0.52, because that's what we found as the Z score. And you'll just see that again and again, and you'll see it in textbooks as well, so I just want you to be familiar with it. So anyway, we're going to go up to our tables then. We're going to go down to 0.5 here, and then we're going to go across to 0.02, which will lead us to 6985. All right, so that means the answer is 0.6985. Is that okay? So the probability that a randomly selected Irish male will be shorter than 180 centimeters is 0.6985. So hopefully that makes sense. We're going to give question 2 a shot now, which is what proportion or percentage will be taller than 185 centimeters? So the first thing we're going to have to do is turn 185 into a Z score. So we're going to go Z is equal to 185 minus 176.3 divided by 7.1. If we want to turn that into a Z score, just stick it into your calculator, and you'll find that the answer is 1.23, right? So now we're looking for the probability that Z is going to be greater than 1.23. All right, so I'll go back up and I'll draw another small little normal distribution. So this is a pretty handy trick, is just to always try and draw normal distribution for your questions. So 1.23, and we want to find the area above that. Okay, so the trick we can use is that we know that the entire thing, so I'll say entire thing is equal to 1. So the area under the normal distribution is equal to 1, or the whole probability has to always be equal to 1. So that means if we can find this area, which we can from the tables, then we can say 1 minus, let's say the blue area is going to be equal to this value here. So the amount of people that are going to be above 1.23. So 1 minus the blue, I guess you could say, is equal to just the orange squiggle, if we want to just talk about the squiggles for now. So 1 minus the blue bit, which is this bit here, is going to be equal to the orange bit, which is what we want. Does that make sense? So if we go up to the table, we're going to find the blue bit, so the probability they're going to be less than 1.23. So we'll go up, we're going to go to 1.2 and then across to 3. So 1.23 is going to be 0.8907. You see that? Yeah. So I'll write that. So that's the blue bit. So it's going to be 1 minus 0.8907 will give us our orange bit. And so our answer will be 0.1093. So that's the probability that someone is going to be taller than 185 centimeters. So hopefully those all make sense. We will be dealing with it again. There's going to be more kind of a little bit more difficult questions in the next video, dealing with the same standard normal distribution, the table. So just make sure you are comfortable with it. I'd say watch it again if you're not quite certain, because you're going to have to do this quite a lot. All right. So hopefully you enjoyed the video. Like and share if you did. We'll see you next time, where we're going to do some harder examples of Z scores. Thanks for watching, and we'll see you next time.